this module, you will learn about hard and soft water. Water is classified as soft and hard depending on the type of dissolved salts and behavior with soap. Soft water produces lather easily with soap and contains no calcium or magnesium ions. A good example of soft water is rainwater. Hard water, on the other hand, does not produce lather with soap easily and cannot be used for laundry. For example, river, sea, and sometimes even well water. The hardness of water is due to the dissolved salts, like bicarbonates, chlorides and sulfates of calcium and magnesium ions. When rainwater makes its way through the ground, it dissolves the salts of calcium and magnesium and turns hard. Let's see why hard water cannot be used for laundry. Hard water contains calcium and magnesium cations, which react with soap to form scum or precipitate of calcium and magnesium salts or fatty acids. Laundry soap contains sodium stearate. When sodium stearate reacts with the calcium and magnesium salts, it forms calcium and magnesium stearate precipitate. Until all the calcium and magnesium ions are precipitated, lather is not produced. This is why hard water is unsuitable for laundry. Hard water is also harmful for the boilers because of the deposition of salts in the form of scales, which reduces the working efficiency of the boilers. Hardness of water can be classified as temporary hardness and permanent hardness. Temporary hardness of water is due to the presence of soluble calcium and magnesium hydrogen carbonates, respectively. There are two common methods to remove temporary hardness. The first method is boiling. Hard water is taken in a large boiler. During boiling, the soluble magnesium hydrogen carbonate is converted into insoluble magnesium carbonate, while calcium hydrogen carbonate changes to insoluble calcium carbonate. The precipitates of magnesium carbonate and calcium carbonate are removed by filtration, leaving soft water as the filtrate. The second method to remove temporary hardness is known as Clark's method. In this method, a calculated amount of lime is added to hard water. It precipitates out calcium carbonate and magnesium hydroxide, which can be filtered off. Permanent hardness is due to the presence of salts of magnesium and calcium in the form of chlorides and sulfates. Permanent hardness cannot be removed by boiling. It is removed by other methods, which include treatment with washing soda, Calgin's method, ion exchange method, synthetic resins method. Let us look at each of these methods in detail. Treatment with washing soda or sodium carbonate. A calculated amount of washing soda is added to hard water. Washing soda reacts with the soluble chlorides and sulfates of calcium and magnesium in hard water to form insoluble carbonates. The second method of removing permanent hardness is Calgin's method. In this method, calcium and magnesium ions are not removed from the water, but are rendered ineffective by the addition of sodium hexametaphosphate, commercially called calgon. Calcium and magnesium ions react with calgon to form a soluble complex. The complex anion keeps the magnesium and calcium ions in solution, not allowing them to react with soap. In ion exchange method, also called the zeolite or permutate process, hydrated sodium aluminium silicate or zeolite, when added to hard water, exchanges cations such as magnesium and calcium ions for sodium ions. For simplicity, sodium aluminium silicate NaAlSiO4 is written as NaZ. Once all the sodium in the zeolite is used up, it is regenerated for further use by treating with an aqueous sodium chloride solution. The fourth method of removing permanent hardness is the synthetic resins method. In this method, synthetic cation exchanges are used. This method is more efficient than the zeolite method. Cation exchange resins contain larger organic molecules with groups such as SO3H or COOH that are water insoluble. They exchange their H+ ions with the cations in hard water. Anion exchange resins contain organic molecules with groups such as NH3OH that exchange their OH- ions with the anions present in hard water. Pure demineralized or deionized water, free from all soluble mineral salts, is obtained by passing hard water successively through a cation exchange in the H+ form and an anion exchange resin in the OH- form. In the cation exchange process, the H+ ions in RCOO-H+ are exchanged with sodium, calcium and magnesium ions present in the hard water. The reaction that takes place is RCOOH in solid state plus M2+ in aqueous solution gives MrCOO taken twice plus 2H+ ions in aqueous solution, where M+2 is a calcium or magnesium cation. Since this reaction releases H+ ions, it makes water acidic. In the anion exchange process, RnH2 in water gives RnH3 plus OH-. The OH- ion in RnH3 plus OH- gets exchanged with chloride, bicarbonate and sulfate anions present in the water. The reaction that takes place in RnH3 plus OH- reacts with X- to give RnH3 plus X- and OH- ions, if X is chloride ion. The released OH- ions neutralize H+ ions. Once the cation and anion exchange resin beds are exhausted, they are regenerated by treatment with dilute acid and alkali solutions respectively. You have now reached the end of this module. In this module, you have learnt that water is classified as soft and hard depending on the type of dissolved salts and behavior with soap. Hard water can be further classified as temporary and permanent hard water. Temporary hardness of water is caused due to the presence of soluble calcium and magnesium hydrogen carbonate. Temporary hardness of water can be removed by boiling and by using Clark's method. Permanent hardness of water is due to the presence of salts of magnesium and calcium in the form of chlorides and sulfates. Permanent hardness of water can be removed by treating with washing soda. Kalgan's method, ion exchange method and synthetic resins method.